you guys know that this is going to be your y-intercept and that is your gradient, okay? C or y-intercept, it's the same thing. So we know that we've got a y-intercept of 0, 3, x, y, okay? And then it goes up 2 and across 1, up 2 and across 1, up 2 and across 1. So it'd be like 1, 5, 2, 7, 3, 9, and so on. Now to find my x-intercept, I'm going to let y equals 0. And you could also do this on your calculator, but I'm just sort of doing it manually. X equals -3 on 2, so it's -1.5, which makes sense because it's sort of coming back here. So it should be about there. If I've used that as 1, 1.5 should be about there. So that's -3 on 2, 0. Okay, so you've got this straight line, right, that we have. So we have this, a straight line that basically goes all the way through these, okay? That's a dodgy straight line, by the way, but anyway. This is an equation. All right, that's a linear equation which we're used to dealing with. What we're going to look at is something like this. Now you do exactly the same thing. Is you'd go, okay, this is my gradient, this is my y-intercept. The thing here is it changes a lot of the things. Okay, let's actually make it also equal to. So if I say, well, if 0 is x, and y is 3, if I look at that point, that would be 3. Is this statement true? That's true. So that means it actually exists because it's equal to. 3 is greater than or equal to 3. Well, it's equal to. So that means it exists on that point. The thing that we want to do is there's actually a whole lot of solutions here because when we're saying equals to, like it has to be 3 equals 3. So if I put in like that 0.03, it's going to be 3 equals 2 times 0 plus 3. 3 equals 3. Well, that's true, right? If I put in a point, let's just say 0.5. If I put in 0.5, if I put in 0.5, let's see if that's true. Obviously, it's not. We're going to say, well, 5. We're trying to see if the left-hand side equals the right-hand side right here. So if I go 5 equals 2 times 0, because that's x and that's y, plus 3. 5, does 5 equal 3? No, it doesn't. But when we're dealing with inequalities, it kind of changes. So let's put in 0.5 here. So we're going to sub in 0.5. Okay, that's what we're going to look at. So this is the main thing that I really want you guys to understand. So if I put in 5 and I go 2 times 0 plus 3, so I've just substituted in 0.5 because this is obviously x and that's y. So y is 5 into this equation, into this inequality, I should say. Is 5 greater than or equal to 3? That's true. So because that's true, that means this point's true, right? Also, if I put in 0.6, well, if I put in 0.6, obviously it's going to be, well, 6 is going to be greater than or equal to 3 because it's going to be 2 times 3. That's also true. Okay. If I put in like, 0.7, obviously you can see that that's going to turn out to be, 7 is greater than or equal to 3. That's true. So all these points here, 0.5, 0.6, 0.7, they all give me true results, like for this inequality. So we normally draw a line because it has to be on that line. But if it's not on that line, well, it doesn't do that. But with an inequality, you actually get like this whole region that's true. Let's look at 0.2. If I look at 0.2, if you substitute in 0.2 into this, it's going to be 2 because we're putting it into this inequality. So this is the inequality rule that we're looking at. So it's 2 for y and 0 for x is equal to 2 times 0 plus 3. Okay, this means 2 is greater than or equal to 3. That is false, okay? So what that actually means is that this whole region in here actually gives me true values. So that means everywhere in here, and anywhere on this side, will give me a statement that's true. Because it's an inequality, I'm really saying, hey, the y value is bigger than 2x plus 3. Well, that, if you think about it, this is y equals 2x plus 3. Well, anywhere above here is going to be greater than, because obviously y is greater than what you had. And that's kind of why hopefully it makes a bit of sense. So all this region, everywhere above there's it. Anything down in this region, though, is false. Because we looked at 0, 2. That's not true. If you put in 0, 0 for the origin, 0 is greater than or equal to 3. That's not true. So it doesn't matter what point you put in. So we said there was a 0.39. Well, if I put in 49, that should be true. If I put in 29, sorry, not 49. If I put in 310, we want to go vertically up, that should be false. If I put in true. If I put in 38, that should be false. Let's have a look at that. So if you put in 3 for x, you're going to have 6. So we're looking at 310, right? So if you just put in 3 for x, and we just don't worry about the other value, so you're going to have y. So it's going to be 2 times 3 plus 3. That's going to be 6 plus 3 is 9. So as you can see here, all the true values for y will be anything that's equal to or greater than 9. So that's why anything, when you're looking at the 0.3, anything above that's all going to be true. But below that would be false. Because if it was 8, then that statement would not be true. So when we're dealing with inequalities, when you've got symbols like this that actually start shading in a region, because it's not like just exact. Because before we say, hey, that's not true. You know, when we looked at the 0.5 and 0, 0.5. But if you change your symbol, well, that becomes actually all of a sudden that statement can become true or it can become false, like depending on which way the inequality is. So with inequalities, the introduction, what I'm trying to get you guys to understand is that it's this region of possible solutions, because I can substitute any value in here and it will make that inequality true. 0 to 5, does that make sense to you while we have heaps of different answers that aren't just on the line? You guys can give me that feedback. That'd be really good. Does it make sense? Okay, yeah, well, if I substitute any value in here into this equation, it will make it true. And you can choose any value, and that's how we do it. Can you see that? You guys are giving me great feedback, I hope. So, nothing. All right. So what I'm going to do is show you how I'd actually graph this. So if I had this question, the first thing I'd do is just treat it like a linear equation. So I'd say, okay, 2x plus 3. I know my y-intercept is at 0, 3. Let y equal 0. Sorry, let x equals 0 to find my x-intercept. Sorry, let y equals 0 to find my y-intercept. So it's going to be 0 equals 2x plus 3, negative 3 equals 2x, x equals negative 3 on 2, or you can just graph it and it will come out. So I know that my x-intercept's here. Now, I know it's an inequality, but it still has the line, so that's fine. Negative 3 on 2, comma 0. Now, once I've done that, guys, then what I want to do is, because it's an inequality, I know, okay, either this region's going to be all true or this region's going to be all true. You need to do a test point above or below the line. Now, the easiest one to do, as long as it doesn't go through the origin, is the origin, because 0, substituting in 0 is heaps easier. So that's going to be 0, 3. So I'm going to sub in a test point. Now, why I call it a test point is basically to see, is it a true or false statement? If this is false, then I know this is all my answers. If it's true, then I know that's all my answers. So if I so I'm going to substitute in 0, 0 because it's just the easiest thing to do, and you'll see why. So I'm just going to do a bit more working out. So it's going to be 0, 2 times 0 plus 3. Is 0 greater than or equal to 3? That's false. So therefore, this is my required region. Now there's two ways you can graph this. One, you can actually say, I can shade that. I could do this. I could shade this. And I'm going to call this my required region. Okay, and I'm going to do a key. And I'm just going to go here. And I'm going to say, required region. So that is my required region. So that is my answer. Let's have a look at another question. Same thing. I'm just going to change this up. Now, this is the same as the other one, except I've swapped the inequality around. So I'd still do the same thing, find my y and x intercept as I would. So I know from the previous equation that my y-intercept is 0, 3, and my x-intercept is -1.5. Okay, now I'm going to put a solid line on there. Why I'm putting a solid line on here is because it's equal to. Because it's equal to, the line, also these points exist. Okay, so I'm going to do a solid line. Now I'm going to do my test point. Now you can choose any test point. It doesn't have to be 0, 0. I mean, I could do 0, 2. Or I could do like, 1, 0. Like I just need to test either above the line or below the line. Okay, it doesn't really matter. I'll do 2, but I'll just show you the origin's easy because you just substitute in 0 and it basically figures it out for you. You don't have to do much maths. So that is going to be, is 0 less than or equal to 3? Well, that's true. Now, because this inequality is different to the other one, that's a true point. Now I can shade in this region on my graph, and you'd shade it all the way. And I'll just do then a little key next to the graph and do lines and call that my required region. Okay, so you could do a different test point. Like I could just say, let's say we do 0, 4. Okay, if I did 0, 4, so then I just put in 4 for y and 0 for 2. Is 4 less than or equal to 3? Well, that's not true. And if you forgot what this symbol means, guys, which I forgot to go through, it's like an alligator. Like the alligator wants to eat more. So, 3 is less than. Or some people remember as the arrow points at the smaller number. Okay, and that should be actually more that way. So that's something that we're looking at. So this is false. So I know that that's false. So that means this is my required region over here. That all this area will give me true answers. So if I have something like this, though, I'm going to do exactly the same graph, except I'm not going to make it equals to. Okay, so this is the same thing. So I know that this is still my required region. How do we graph this is a little bit differently. When it doesn't have the equals to line, we actually just do a dashed line instead of a solid line because it doesn't equal those points on the line. So you're actually going to do a dashed line and then shade in your required region. If that makes sense. So again, you'd still have your points, 0, 3, -3 on 2, 0. And when it's not equals to, you always do it as a dashed line. Because if it equals to, we do it as a solid line, right? And that's why. When it's equals to, we do it as a solid line. So when it's not equals to, you do it as a dashed line. And that's pretty much it, guys. That is it in a nutshell. All you need to do is do a tested region. If it's false, then it's not the other one, and vice versa. One thing that's really important, you should always have a key there. Now I am going to flip it up a bit and just show you like another graph. I'll just do a different one altogether. Let's go with y. Let's do it like that. Okay. So here, if I've got y is greater than 3x, well, if you think about 3x, it doesn't have a y-intercept, it's got a gradient of 3 on 0. That goes through the origin. Now, I know it's going to be kind of like this, okay? Because it's not equals to, it's going to be a dashed line. Now I've got to do a test point. My test point can't be the origin in this case because it goes through there, okay? So I need to do a test point somewhere else. I'm going to do it just maybe here, whatever I'm going to call that. I'm going to call that like, I'll do it here, 1, 0, 1. Okay, so if I put in 0 for x and 1 for y, is 1 greater than 0? Because if I substitute that in, it's going to be 1 is greater than 3 times 0. That's true, right? If I do that. All right. So this is my true region. Now, what I'm actually going to do is shade out this area. And I know last time you're like, that's not your required region. But I'm going to show you something. And while we do that, I'm going to then do this and leave this blank. Oops, sorry. Ignore that. Just ignore that completely. I'm going to then give a key, and I'm going to leave that blank and say that's my required region. Now, why do I do that? That means all this is my true region, and that is fine. That is perfectly fine for that, because I'm saying it's not there. Why do I do that? Because later on, when we look at doing two graphs together, so if we've got y equals, say, oops, y is 3x, and we've got we'll do that one. This is where we're going to move to next, where we're going to graph two of them together. When we start graphing two of these, I'm going to show you. So we've got this region here, which is 3x. Now I know that this is my required region. Now, if you shade in the required region, okay, I'm going to shade in the required region. I'll show you why we don't shade in the required region. That's what I'm trying to show you. And over here, I know that that is y is less than or equal to 3, which we have as this one here, which is our required region, is underneath. So where am I? So that's going to look like 2x plus 3 is underneath. So it's going to go at 3. These are going to intersect at 3 would be 9. Yeah, they're going to intersect over here at 3, 9. Okay. Let's call that 0, 3. That's 0, 3 here. So that is 0, 3. Okay. So this graph, and that's negative 1.5 over here. So this graph, because it's equal to, will come along here. And then it intersects there, and it goes that way. And that graph starts going that way. Now, this is my required region here. Now, if I have to graph these two together, and now this is my required region for this graph, is under it, right? So it's all over here. Let's just double check that we've done that correctly. We'll just use a couple of test points. Okay, so what if we look at, we do a test point here of 0, 3. That's going to be 3 is 0. That's true. So that means up here is true for that one. And let's do a test point below. Let's put in the origin. That's true because I've put in 0, 0. Okay, so that's true. And I've put in 0, 3 for this one, and that's true. Okay, so down here is my required region for that. Where the required region is for both of these is where they overlap, because this is where they're both true. So then you've got to look for where they're both true, and that is my required region for both graphs. And that would be a solid line along here, and it would be a dotted line along this side. Now, why it's really hard is because how are you going to show that as a key? When you start doing 3 or 4 of these together, it's really hard to see where they are. So why I encourage you guys to shade out the region that's not required rather than required, and you leave required region blank. It makes it a lot easier. So I'm going to show you what I mean by that. So I'm going to put in that 0, 3 line again, which is dashed up here. Okay, and then the other line was pretty solid, and that was going like across here to here, and it sort of intersects there. Now, let's just look at this a bit. If I shade in the area that I don't want, so for this one, we knew the false area was below. So let's shade in this all below. Okay, we're going to shade in all this area below the line. And then the area that I don't want for the solid line would be on the outside. So then I can shade in all this, okay? Now, the beauty of this is by doing it the other way is that your required region is the area that doesn't have any shading in it, which is this area. So that's your required region. So why I encourage you guys, and this is for later on down the track, is to shade in the area that you don't want and then do a key as the required region that's blank, is because when you start graphing 2 or 3 of them, it's a lot easier to see. You're graphing out the area you don't want, and then anything that's not graphed, anything that's not shaded is your required region. So you'll find your CAS, and that does it a bit differently, but I'll do it the other way around. So with your CAS, if you guys grab out your CASs for me, you can actually do this as well in graphs and tables. All we need to do, and we will need to set up your CASs correctly, but how you graph these is you just change this type to the inequality that you want to test, okay? And then I can just put in 3x. Hit OK to that. I can then graph that. Oops, no items checked. We just graph that. And you can see that that is, whoops, zoom quick. There we go. You can see where that's graphed. Now, you'll notice that your graph has shaded in the region that you've required. Now, you do need to set this up in settings. If you go into here and then you go to graph format and you want to change this to union, that's really important. So your calculator will be different. So you really want to go in there and do that to there. The reason for that is because once you start graphing a couple together, and let's just say we also want to overlap it with this. So now I've got to change this type to the other one because it's that, and that is 2x plus 3. And say if you get it wrong, you can actually double click on here and you can change it to what it is. So there. And then if you graph both of those, it will do that and it will do that. Now you can see there it does the union. Sorry, we don't want union. So the union here, you got to see where it overlaps and it's really hard to tell. So what you want to do, you want to actually change your graph type from union to intersection. Okay, that's what we want. Sorry, I stuffed it up. Then you hit set to that. And then what you'll find is it will only color in the required region. So you want to go up into here, graph format, and change it to intersection. Because if it says union, it gets really hard to see. They do what we do here, which is like the first thing, which is like, oh, let's just shade in every region that's required. So your CAS automatically shades in the required region. And the problem with that is you've got to kind of see where it is. And when you put 4 or 5 on, it's really hard to tell. So if you change that to intersection, it means it's only going to show where they're overlapping, where they're intersecting with each other. So do that one. If you got the TI, just try and make sure you got that one. That should be your answer. Really, I'll just shade in the area you don't want and leave your required region blank. That is it from me today. As I said, there's probably about 5 questions for you guys to do. You should be able to knock that out of the way. Have a crack at them. It does say sketch the inequalities. In, I think, Ed Rollo, they may have the shaded region. I think they've got the shaded region as your required region. As I said, as long as you've got a key, you need a key on your graph to show what the required region is. It is fine to do it either way. Typically, if it's one graph, though, I shade it in personally. And if it's not, then I do the opposite. But yeah, so that would be what you'd want to do. That really helps with how we graph and we can see it. Stop recording. Any questions?